this is how it all started. I think this was about 3 years ago. I catch the buses a lot in Bristol, and I do programming. I'm interested in data, and I thought how cool it would be if you could just have a map, like a Google map on your phone, and then just like press one point arbitrarily anywhere in a city, and then another point arbitrarily in another city, and it would figure out the best way, the best buses to get. So some kind of clever route finding algorithm that would like, because I mean, if buses are like, some are really frequent and go down some routes, and some aren't so frequent, some don't run on a Sunday, you might have to, sometimes you have to change buses and walk like maybe 5 minutes, but that's a better option. There's so many factors involved, but there's not, I mean, it's a different thing with trains, because it's a very rigid, there's not very many variables involved. There's some kind of clever application that could weigh up all the factors and give you like a hierarchical list of the best options. Like the best one might be the quickest, but then you might get ones that aren't so quick but are more frequent, or you might be able to like produce a heat map or something. Anyway, I'm digressing here. The point is that this data is publicly available. What used to be called the MPTDR, but is now the Travel Line National Data Set, which is a wonderful data set, a lot of data, the geo coordinates for every single bus stop in the UK, every single journey. I mean, there's just so much amazing stuff we could do with that data. And I started writing some stuff. I still got some code from about 3 years ago. And I started having success, you know, it was all like web sockets and getting some, you know, basic results coming back. Then I was like, oh, this is going to be great. I'm going to host this, and people are going to use it, and I'm going to become famous and travel the world, and it's going to be great. I'll be able to retire and all those kind of things. So the problem that I saw was that in order to be able to run the kind of queries on this to make it a usable service, I'd need a 2 gigabyte, you know, either some decent indexes on Postgres or to put it in Redis or something to get the kind of responsiveness that you'd expect from an application like this. So to do that, let's say be generous and put this 2 gigabyte data set in Redis Cloud on Heroku, it's $252 a month, which I can't afford, and that's a hard thing to bootstrap. I mean, I suppose I could take this idea to some entrepreneurs, I could get some funding, but you know, I'm not really into that. You know, this idea I wanted to be for the benefit of everybody. I wanted it I still want it to be, you know, just an open thing that everybody benefits. I don't really want money to be involved. So then I thought, this is when I started thinking about, this idea, which is, this is basically looking at Wikipedia and saying, well, look what Wikipedia have achieved. Wikipedia, and what they've achieved, is a business model whereby they essentially take donations, voluntary donations, and they have one of the highest traffic websites on the internet. I don't know what their hosting costs are, but I suspect they're humongous. Yet they managed to keep going, and you know, I'm sure a lot of us have donated whatever pounds and seen Jimmy Wells's face on the top of the website. It worked. It's a proven model. So I was thinking, what if we could somehow formalise this, but in terms of hosting? This is all nothing to do with peas really at the moment. It's just still a digression. So the basic idea of Dynavox, again, this is something that I've prototyped. It doesn't completely work yet, but the basic idea is it's Heroku, but with public payment pages. So you can still, I mean, they're public payment pages, so you can still use it as if it was Heroku, except that anybody else can pay as well, in kind of the same way as Wikipedia works. So I was thinking you could also, for free, if you hosted on Dynavox, and you could do things out of the box, similar to Wikipedia. As in, so say if your hosting costs are currently like $30 a month, and people aren't donating enough money per month, say they're only donating 35, then you could automatically have a banner appear above your application's website that said, please donate some money, and you could have maybe some graphs that were like a graph of the hosting costs over the month or the year, and a graph of how much money is being donated, and you could see at a glance how much more money this application needed in order to stay online. And some applications would go offline because nobody would be using them. But in the sort of same way as a laundrette or something, you come along, it's there, you just put some money in, and the thing fires back up, and there it is. And then I got really excited about this idea, and I thought, wow, what if we, like, this I thought could actually bring down Google, or it could be the next thing. What if, like, all of our essential services, email, search engines, I'm not against making money off the internet, but I think there are some things, like search engines, that should just be like the roads and hospitals of a nation. They should just be there. We shouldn't be worried about corporate interests and agendas skewing what is essentially just being able to search for data on the internet. So if you had some kind of laundrette type paradigm for search engines, then that might be a wonderful thing for the internet. Who knows? I don't know. It's a social experiment more than anything, but I thought I still do. So anyway, so this is really the big dream of mine, and what I'm trying to bring into reality. So in order to do that, I'm having to basically build Heroku myself. I mean, I did think about talking to Heroku and saying, could I have an add-on? Could I create an add-on that integrates with your API where it has a public payment type? It wouldn't work. It's not a good idea. So I got to build Heroku myself. And that is pretty... I mean, you were talking about very high availability, elasticized infrastructures, software. I mean, there's so many parts to something like Heroku that it's a bit overwhelming. So when I first started, the two big things out there were Cloud Foundry and OpenShift later on. OpenShift's still fairly new. Interestingly, both of these things are largely built in Ruby. Back in the day, this was before Docker, these things, still using containerization, LXC, which I'll talk about a bit more soon. I looked into Cloud Foundry and started learning some of its stuff. Very steep learning curve. I just felt it was way too complicated. I just needed to be able to hack some stuff, like being able to add the concept of uptime and credits and that kind of thing. It was just way too much. So I came across this thing called OpenRuco. Has anybody heard of it? I doubt it, because it's very obscure, but very well built. No longer really maintained. Heroku compatible. I really do. I think OpenRuco, the jar is their logo, was the first open source serious use of Heroku's open source tools. So things like build packs. I assume most of you know what the build pack concept is. It's a very convenient way of turning any application, Node application, Ruby, Python, whatever, and turning into a kind of like a binary, I suppose, like a slug that can just be run anywhere. And the build packs do a really good job of just plug and play, fire and forget. Just put your application through a build pack, and suddenly you have this thing that you can run, and then just like copy in dynos, containers, dockers, whatever, and just have squillions of them, and you can, as long as you put a nice proxy in front of it, then you can slash effect. So OpenRuco, its command line client was completely compatible with, it still is, with Heroku's API. It uses Logplex, which is another open source thing from Heroku. It uses Heroku, well, it doesn't use Heroku's rendezvous part. It borrows that concept from it. The rendezvous being a way, so one of the things that you do that you've probably all done on Heroku is, like, from the command line you've done Heroku run rake console or something like that, and it brings up a console. In order to do that, you're creating a socket connection in real time that's sending and receiving PTY data, and that. So the rendezvous concept is a really very good, clever thing from Heroku. So you start from the command line, you make an HTTP REST request from the command line client, which returns a token, which allows you to then drop down to a socket connection from the command line client. And the rendezvous thing is a little bit like the HTTP proxy, but it's a socket proxy that allows you to have direct access from your command line to an individual one-time LXC container or Docker container. So OpenRuco, I built a prototype of Dynabox in OpenRuco. I was one of the main contributors to OpenRuco for a while. I helped move it on. I learned a hell of a lot about this concept of platform as a service. So it was really my introduction to this whole field. But OpenRuco wasn't really maintained. It was written in Node, so it was not something I'm naturally familiar with. It wasn't particularly easy. The testing was just, no one was maintaining it. I wasn't enjoying it so much. It was becoming increasingly a big effort to get anything done with bugs. So I just dropped it, by the way, so I kind of gave up and forgot about it, really. And I just thought the whole thing was just too much for me. It's too big and daunting a task. And then, interestingly, these chaps tweeted me, just saying, "Oh, I saw your work on OpenRuco. Do you want to help out, get involved?" And I became very involved with Deus, to the point of discussing moving out to Boulder even to work with them. So I was heavily involved with Deus. I was a lot more excited about Deus than I was OpenRuco. Much more maintained. They had a round of investment money. It was written in Python. It was much better documented. And this was my introduction to Docker. So, okay, let's have a think about Docker for a second. When I first heard about Docker, I was like, what? It's just a wrapper around LXC. So what? What's the big deal? And I still kind of do think that in a way. But Docker has become massive. It's just become this phenomenon that has swept the world with its glory, and everyone is now basking in the glorious sunlight of our divine new toy.
How hard was LXC to use before Docker? I don't actually know. I've never actually used LXC directly. Was it difficult to bring everything together?
Yeah, definitely more difficult. But I wouldn't say significantly more difficult. That was my skepticism. Although I didn't have to, in the case of OpenRuco, start from scratch with LXC. There were a bunch of batch scripts that did all the C group type stuff, and built the initial file system and the mounts and all that kind of thing. So I didn't have to think too much about that. But it's still, maybe only a few hundred lines of bash to be able to do something similar to Docker. So just I'm sure most of you are probably familiar with the concept of LXC and containerization, but just to flesh it out, for my benefit as much as anyone, just to remind myself of why this is so exciting. Basically, to my mind, containerization is a lightweight form of virtualization. Containerization is not virtualization, although it ultimately achieves the same effect. Virtualization actually, so that's VirtualBox and similar things, they actually emulate hardware. So with VirtualBox you can actually emulate CPUs, which means you can actually you can run Windows or OS X, or it's a complete, the software running it in it has absolutely no idea that it's virtualized. It's a very, and quite often virtual machines use obscure parts of the CPU itself to do the virtualization, and I think there's overhead to that. Ultimately, it is a lot more powerful, and it has its place. But containerization, so LXC, amongst other things, I mean, there's OpenVZ as well, there's libcontainer, which now Docker defaults to, which is their own kind of containerization technology. Containerization, really, in my mind, is just, all it is isolation of resources. It's just saying to a process, you can't have this bit of memory, you can't have this bit of the file system, which creates this kind of illusion of being a separate machine, but it's not a separate machine at all. It's just like a kind of firewall, if you like, that on a good day prevents nothing going in and out that shouldn't go in and out. Or, you know, I mean, you might have heard about the recent security incident with pre-version 1 of Docker. So it's not perfect yet. I mean, what this means then, containerization is much more lightweight. It's much quicker. You don't. There's less overhead. It just happens instantaneously. Creating a Docker container is as quick as writing a few files to a file system and making these rules, and suddenly you have this container. So what it means is that, in the case of Heroku, I don't actually know whether Heroku uses Docker. I'm sure they're probably thinking about it now. I think they do use LXC. So what it means is that you can have, ironically, a virtual machine or just a complete computer and have a bunch of lightweight containers running inside a virtual machine or a computer, and each one of these containers contains an instant of your application. So a web request comes in to the front of, say, Peas or Deis or OpenRuka or Heroku. The proxy at the front, which is just a normal proxy like Nginx or Apache would do, it looks at the web request, looks at the domain, and it takes the subdomain and goes, is that an app that we have on our system? Looks it up in the database and finds on what computer containers, there could be many containers, are available for that app. And each container, they could be on separate machines, there could be 2 or 3 on one machine and 2 or 3 on another, but the database has a record of where they all are, and each container has its own port. So the proxy at the front, this was another big thing on Hacker News a while ago, is about how the way in which the HTTP proxy chooses which container to forward the request to. Apparently it's random, and still is random on CEDA. So
it's ended up costing loads of people more money because they changed it.
Oh right, well they've changed it from random to something like clever, like round robin.
No, it used to be clever, it's now random,
Oh,
and now it's costing around 40% more.
Oh, I see. So there's all kinds of discussion about ways to circumvent that kind of thing. So the proxy then forwards a web request to like an IP address with a host name, an IP address with a port number, and then that instance your application response to the web request. So it's a lovely way of like scaling, because it's kind of just like, it's a bit like you just throw stuff. You just throw more machines, and it doesn't matter where the machines are. You just throw some containers in the machine, and they can be anywhere, and somehow it all can scale to really large, and it all just works out. So Docker, what Docker does to containerization, it does nothing new. Containerization was around a long, long time before Docker.
Not sure if it started with Solaris, because I used to work with Solaris zones, which is part of virtualization.
Right, yeah, it was a very similar concept.
Came into Linux in 2007, so
What did
LXC.
LXC did?
Yes.
I thought one of the main reasons for bringing Docker in is you needed to limit what's being sent down, because they all share the same kernel. If you find a kernel security flaw, you can crash that stuff.
Yeah.
So it's kind of like the router is to limit how much communication.
That could well be true. I don't actually know about that, but that's true. The kernel itself is shared between all containers and the host system. Yeah, that's the one thing. Which is why it's hard to run on Windows and Mac. That's one of the drawbacks of containers, not just Docker. So what Docker has done, and all Docker has done, as far as I know, is a convenience. It is an API. It is a consistent, very well made API around containers, and not even LXC anymore. You can just drop in and drop out any kind of containerization technology. Interestingly enough, I only found out through doing these and working on this that Docker actually has a REST API itself. You don't actually have to use the command line to do all the talking to Docker itself. It has a RESTful API. So that's a beautiful thing, that you can talk to all of your, create containers, do all of the beautiful things you can do with containers through a RESTful API, which is nice. So Docker has taken off, and it has been massive, and it's not just being used for kind of platform as a service type things. It's being used for all kinds of things. Just the beauty of being able to do Docker pull Postgres, say, and you've just suddenly got a Postgres database set up straight away. Or, you know, some complicated application you don't want to install the dependencies for, you don't want to like you don't want to mess your system up because you're like, oh, do I have to put that version in, blah, blah, blah. And then you just do Docker pull, complicated application, Docker run. It's brilliant.
I find it quite difficult to trust the applications you get from the index. How do you know who's compiled these applications? And also, because the way they're stacked up, how do you have to trust people who built the Ubuntu-based system and what others like stacked on top?
I think the popular ones, Docker, have verified themselves, though.
Right, yeah, but I'd still sort of be nervous.
I mean, if you're using like Ubuntu as a base box, which
Yeah.
I think all of the things that you want to use as a base are all pretty much verified. I think anything.
Well, I think they're verified in the sense that Docker builds them. It builds these trusted builds themselves, and it will only pull from public GitHub repos.
Right.
So it's all public. It can all be scrutinized, and there's a paper trail to commits, and you can see this build comes from that publicly available commit. I mean, I'm interested, how would you say that's different from like a package management system? Just because it's...
Well, I choose my operating system, I have to put trust in the Fedora processes.
Yeah.
I'm just not sure whether I trust the Docker processes as much.
Docker's own Ubuntu build have like PGP key that you can install on your system to verify that the download, also verify that it, downloaded without corruption as well as making sure it's genuine.
Yeah, it's true. Yeah, it's exactly the same problem with the vagrant boxes in the open boxes. I mean, they must be very much the same image as well, really, because basically they're just an image of the file system. And you could presumably do conversion between the two.
Yeah, I had a French version of Fedora or something the other day.
And they're French.
Absolutely right.
Deus. Deus is one of the. Yeah, I think Deus and Flynn at the moment are the two big players. Well, my two favourite, Cloud Foundry and OpenShift, are massive, much bigger than Deus.
I think OpenShift is moving to Docker as well.
You say that again?
OpenShift is moving to Docker.
It's moving to Docker. Yeah, I see Docker mentioned on OpenShift quite often. Yeah.
Because they have the concept of
Cartridge.
cartridges, which is
Yeah.
similar, and they're moving that to Docker.
Yeah.
Because it's most the same concept, but
Yeah.
like Docker is standardizing that.
Yeah. And you've got to be
Cloud
seeing.
Foundry is as well, they said that they're gonna replace Warden with Docker.
Replace what, sorry?
Warden is Cloud Foundry's container technology, so they're gonna use Lib container instead.
Yeah. You've got to be seen with the right clothes on, haven't you? It's all fashionable.
Can you just,
Yeah.
sorry to prolong this.
Yeah.
Just explain what DS and Flynn do, but what do they offer on top of Docker? Is this where you said you have a proxy in front and they will
Yeah, exactly.
That's what they do.
Sorry, so Deus, Flynn, OpenShift, Cloud Foundry, Peas, platform as a service. So basically, it's being able to do git push. It runs a build pack. Suddenly, you've got an instantly scalable application. That's what platform as a service does, like a rock. Yeah. So Deus is just another one of these.
Is it unlike Ruby in the sense that your application type is managed by your Docker file or something, or do they say spin up a Redis like server or something?
What Deus?
Yeah. I didn't know whether it was defined by like the client where you're pushing your spec for what you want up, or whether like Ruby says, I want Redis on this and you push to that.
Well, I'm not sure I get exactly what you mean, but like on Heroku, you add Redis after you push the application.
Yeah.
So, how do you mean? I wouldn't, not all, it depends from pass to pass, whether they offer services as well. I mean, on the whole, most of them do actually allow you to have services as well, so you can use them to provision MySQL and Redis and all those kind of things. But I wouldn't say that's a necessity for a pass to be complete, because you could quite easily provision the Redis service separately yourself. As long as you provide the credentials, then it's fine. Interestingly enough, Deus, as far as I know, is the first platform as a service to allow you to push a Docker file. So rather than like git push your application and the build pack is applied to an application, they're just doing it so it's like, if you've got a Docker file, we'll just create squillions of whatever this Docker file is and distribute it instead of the build pack.
That's what it means. I mean, if your Docker file kind of has like Redis or baked in, will it just use that? Or push to a Redis like style application?
Yeah, Deus does that. But that's new, and I've not seen anybody else do that.
That's really awesome.
Yeah, that's really
But
good.
presumably you have to find the ports,
Pardon?
because if with Redis you're not, I mean, if it's a web app it's port 80 on HTTPS, but if it's Redis it's going to be a different port, so you'd have to define what that is as well.
Your Docker file defines that.
The Docker
Yeah, your Docker file would use expose ports. And you can even export expose. So say you've got SSH configured by default, so it's on 22, but you don't want that on. You want that on maybe 2222, so that it's a bit more secure. You can even kind of put that bridge there in your Docker file.
Yes.
Oh, has there not been hosted Docker for a while? That's actually what it is.
What hosted Docker? Yeah, it was one.
Docker is a service as well.
Yeah. I wouldn't be surprised. I don't
There's
know.
TomTom and Orchard are two Docker hosting services, and then Google Compute, Rackspace, Software, Amazon are all working on like
Just
Docker hosting services.
Yeah.
Yeah, I think Deus is the core unit that the service acts upon, but it's a lot more than TomTom, where it's basically you just go there, you post your Docker containers, and you do whatever you want with AS. I think provides services for orchestration and then networking and proxying and all those types of things on top of it.
Right, so Python and Chef. Python is nicer than Node to write. Certainly good at that. Although it's not, as we'll come on to, concurrency, the whole concept of a path is about concurrency. Like concurrency is fundamentally baked in. Python doesn't really excel at that, nor does Ruby, to be honest. And Chef. Chef. Brilliant, but I didn't like it. Chef has its place, it's brilliant, but as I'll come on to in P's, what Chef wasn't, I wanted something really simple, and Chef I just did my head in. It takes so long to like just even boot up a development version of Deus or any of these things. Getting Chef running through all its recipes, making sure you have to have a Chef server, because you've got to set the Chef server before you can do anything else. I got a bit frustrated with this because I was doing a lot of work for them, and they weren't going in the same direction I wanted it to go in, and they weren't responding to PRs as quickly as they should. Let that be a lesson to all of you GitHub Dispo hosters, respond to PRs. Right. Yay! Please. Right. So, fuck it. that is the gist of it. Like, so I've been heavily involved in 2 significant past projects, understanding them from the foundations out over about 2 years, and I was like, do you know what? I could fucking well do this myself. I mean, it was a daunting task, but I was just like, this is the only way I'm going to be able to create the thing that I need to create in order to create the Dana box in order to have my fucking bus timetable. Just want to cash a bus. That's what this is about. So, because there I am, like building OpenRuco and Deus, and the whole time I was just thinking, I wish this was Ruby. If only this was Ruby, this would be a load of fun. I would do this, I'd do that, blah blah blah. And so basically this is it. I just got to do whatever the hell I like. I've done it exactly how I want it to be. I've like taken the best bits, got rid of the worst bits.
Are they suing you?
No, they're very supportive. Yeah, it took me 2 weeks to prototype. I hardly slept, because once the idea was in my head, and I was like, shit, I can actually do this. And then I'm front page of Hacker News and second most trendy repo on GitHub. I mean, when it was like, that's probably the biggest accolade I've had in my career. When I found out that I was on the front page of Hacker News, I literally got up on my table and danced. That's how happy I was. But it hasn't really seen the kind of, people haven't really been using it a huge amount since it's been released, and I think that's because it's not ready for a start. But this combination of Ruby and Docker, these 2 buzzwords, I just think that's just it's like catnip to geeks. Like, Ruby and Docker, wow, it must be amazing.
Throw in Mongo and it's just like,
yeah, throw in Mongo.
Oh my god.
Oh my god, people are falling over themselves. So to be honest, I think that's a large part of it, why it was so popular. Can I talk about, so what's different about it? I think the main thing is that I am not trying, Peas is not, it's not trying to be this massive enterprise, do everything, take over the world. I want it just to be kind of want it to be educational in a way. It's like the go-to one if you just want to learn about paths. I want it to be well documented, easy to use, low barrier to entry, low learning curve. It's not going to be as good. Well, I mean, it's going to be good, but it's not going to have the kind of features that the other paths have. One of the big things is, like, I'll talk about this later, is bundle exec guard. That is, as long as you've got Docker and Mongo installed, that's it. Bundle exec guard, and you've cloned, that's it. You don't need to install Vagrant, you don't need a chef server, you don't need chef, there's no provisioning, there's no fixtures to install. It is just, it's like a Rails app. It's not, I don't use Rails, but I want it to be as simple as firing up a Rails application and just hacking on some code. Ruby, this is my opinion. Ruby is the easiest language to think in. It's not the best language for some things, but it just allows you to kind of, I just like throw code out, and these are my thoughts, and then I tidy it up, and Ruby really allows me to be expressive and not really think too much about the language itself. I don't want any other language in there, not because I'm zealous about Ruby. It's just that, I just want to keep it simple. If there are some things I can't achieve by just having one language, then so be it. There has to be a bit of Bash in there. Bash is the glue that binds the universe together. So that's, yeah. Okay, right. RSpec. Right. I love RSpec, and really, I've only been programming Ruby for 2-3 years, and before Ruby I didn't really test much, never really understood it. But RSpec has introduced me to a whole new world, and there's something about RSpec which I really, really love. It's this, and the reasons I give it, it's this idea that the programming is not a finished product. It's something that lives. It's never the same 2 days in a row, and you have to keep. And software is constantly changing. And for me, RSpec acknowledges that. And I love how the way testing, like at work, how my boss hates it. Like, well, why are you testing? Why do you need 2 weeks out to write these tests? What does it achieve for our product, our service? How is it going to make us more money? I love that it irritates him. Because to me, RSpec is like saying, let's make the living room nice. Let's have some plants. Let's get some nice chairs. Because it's going to be fucking horrible writing this software. Let's admit it. And anything we can do to make that nicer is a bonus. So RSpec is just like, let's just acknowledge that writing software is shitty, but we can make it more fun. So this is by far the thing that I most miss from working on Deus and OpenBRUG code is a good, enjoyable testing framework. And I've written tests right from the beginning: API tests, command line tests, integration tests. So I'm actually booting up Docker containers, getting the command line to actually talk to Docker containers through an actual proxy, and all through Travis. So I just fire off a commit on Travis, and Travis runs a shit ton of tests, and man, it's just like going to bed when everything's green. It's nothing better than that. So RSpec, right at the top there. This is what makes me happiest about working with people, is RSpec. Some other cool things, Puma, I don't really know why it's better than Unicorn. Some people say it's better performing. So this is just, Puma's just the web server. Should we put on with that? Rack. I mean, I don't dig into Rack that much, but so I'm not using any kind of, I'm not using Rails, I'm not using Sinatra, I'm using something called Grape, which is an API DSL, which I'll probably come on to. So Rack is really kind of the nearest to an HTTP framework. really all I do, the only thing I talk to Rack about is the proxy, the thing that actually does, it looks at the incoming web request, looks at the headers and goes, and does that thing I was talking about, looks up some stuff in the database and then forwards on the request to the document container. So yeah, so you've got your rack up, your config.ru thing, and I just got my API and my proxy, and that's all it does. Yeah. Oh, so here's an example of a forwarded web request. Yeah. So that'll be the so in a development environment, everything just runs on localhost. So you have some kind of string manipulation, you know, that splits it on the dots or whatever, and then you get that, look that up in the database. You get a bunch of, I call them P's. That's a nice name for, because so P's is a portmanteau of pass for the people, but it also has this nice visual metaphor of peas in a pod, dinos in a BPS or whatever. I'm a big fan of Mongo, and actually off for no other reason that I don't have to write migrations. That's it. And I think that's especially relevant with P's. That's part of P's concept. It's like we're not making. P's is never going to be like some massively high availability, pure, true Heroku replacement. I don't think I'm ever going to need something that performs like Postgres or something. Mongo is perfectly good. We don't need migrations. It's kind of rough and ready. Like P's is just like a kind of a base for hacking on. You want to do something like me, like produce Dharma box. There could be multiple things you want to do with the pass, and you want to add your own fields to a model, no migrations.
What do you mean by no migrations?
So when you're creating a web application, so when you've got versioning, it's really good to be able to roll back your software or take out a commit from earlier on. Versioning allows you to be a lot more rough and ready about it. You just build stuff, delete stuff, you don't worry about things. Of course, one of the things that is hard to version are the database structures or your database schema. And you can version, if you like in an MVC kind of type thing where you're defining classes and the fields in a class that represent columns in a table, in a database table. So say in an SQL setting, you have to, in SQL, you have to define a database structure. You have to make SQL queries to the database to say, this database table has exactly the same columns as fields, properties in this class, and there's a one-to-one match between the model, the class model, and the database table. But as you go along and change, I don't want that field anymore because that's rubbish, we want to add another field, then you have to, in an SQL setting, you have to write migrations so that as you move between versions of your model, you have to synchronize.
You're not talking about data structure migrations versus like the server needs more RAM, and so I need to migrate the database itself.
Yeah, exactly.
Okay,
Which is what you have to do in SQL, and that's just the reality of life. But with SQL and Mongo in particular, there's no database structure. You just shove stuff in there, and it doesn't care. So the Docker, I talked about this earlier. So Docker API is just a wrapper to the Docker RESTful HTTP API, which is, and the beautiful thing about this, circling back to RSpec, is VCR. So who's used VCR? Well, I hadn't heard about VCR before this. You've probably all heard about stubbing, being able to stub stuff, like, which is really good in testing because you don't want to actually have to, like, you just want to isolate little bits of code, and so you don't use the real thing that talks to that, all things that talk to the bit you're testing, you just have So what happens if you're testing things that make web requests? So yeah, things like you've got a bit of code that does some web scraping and you want to test that bit of code. Do you actually get asked spec to like make the actual live web request? You fall into all kinds of trouble then because you like your tests rely on a live internet connection, so you can't run your tests on the train or there's lots of reasons why you wouldn't want to do that. But also you have to rely on an external HTTP request consistently returning the same response so that your tests are idempotent and all that kind of thing. So VCR, it comes from the VCR tape player thing, which allows you to stub actual HTTP responses. So you can do this with sockets as well as HTTP requests, which is handy for streaming, which happens a lot in Ps. So if it wasn't for the Docker API gem, I'd have to be using the command line. So I'd be shelling out. I'd be using shell or exec or backticks or whatever to talk to the Docker binary on the command line through a shell, and it's just flaky. It's not a great way to be consistently testing things. It's hard to like isolate the arguments and slip in different arguments and that kind of thing. So having an HTTP wrapper makes it much more solid. It's much more reliable, much more consistent. You're not dropping down with backticks or shell commands. You can stub with VCR. So VCR looks at the web, the HTTP request, and as long as it has a tape that exactly matches that web request, it just replays you what it recorded the first time you ever made it. So that is really handy. So it makes the specs much cleaner and much more reliable, more consistent. So you can test the code in a very real way, but without having to rely on external HTTP requests. And as far as I know, none of the other passes have this kind of testing. They're testing. Well, a lot of the other passes are using integration tests. So their code does have coverage, it's being tested. But I think I don't know anybody else who's doing this kind of isolated testing of units of code.
So you've got a fake Docker API.
Yeah, exactly. Yeah, so these aren't external web requests to like Google or something like that. The Docker API runs locally.
But you can run the test even without the Docker API daemon running.
Yeah, and the code knows no different. They're completely genuine.
Does it act like a proxy? So can you, when you first develop a test, are you actually going through the VCR to Docker API, recording what the tests are right? Is that a really thing, or is that something that's...
I think it started as really, but now I think most languages have this, and I think they're all called VCR as well. Yeah, Python, JavaScript. Yeah, it's really useful. So this is it's another gem. So this is the command line client. So when you're doing things like Ps create, or Ps deploy, or Ps scale, that kind of thing. But equivalent to your Heroku commands on the command line, I'm using just a really nice gem, which has this nice DSL, which probably think of RAID files when you look at that. You've got description, so you put so this is Ps config remove. So this little block will allow you to remove a config. So config being in Heroku would be like your configs where you put your database credentials, your Redis connection, that kind of thing. So this little bit of code just removes a single key from your config. So it's nice, a Git-like interface in the sense that with the Heroku command line, I think it actually uses the RAID concept of separating commands with the colon, which I'm not such a fan of. I like the Git syntax, so just a really handy, quick, easy way of writing command line apps. I don't have to think that much about what I'm doing. Okay, so this was a big deal. This is, like, as I said earlier, I touched on earlier, concurrency is like a fundamental concept within a path. You're having to deal with hundreds, thousands, millions of simultaneous processes all at once. Like web requests coming in, being funneled off to different dynos, containers, Dockers. The Docker containers, they're constantly talking back to the controller about their health, whether they're up or down. So there's messaging going in between. You've got workers, so Sidekick, I mean, I'm sure you've all kind of come across that concept of being able to, like, not, you know, so during a web request, you don't want to wait for a long running job. You just want to get a job ID instantaneously, return the web response, and then you can just watch the job's progress and get an update later, either through a streaming socket or a long polling HTTP request. So there's a lot of simultaneous things going on within a path, within any path. And I started off by thinking that I would use Sidekick, which I did, and NATS. So what's interesting, so NATS is just PubSub, but PubSub concept, I'm sure you're all familiar with. The interesting thing is that Sidekick and NATS use two different concurrency paradigms, being celluloid and event machine. This is all new to me. I mean, concurrency, as far as I'm concerned, is JavaScript callbacks. That's kind of really my knowledge of concurrency. But this has had to, so I've had to learn up about things like the actor pattern and the reactor pattern, and having to think about threads, thinking about race conditions and mutexes and that kind of thing. And event machine is quite old. It's not really maintained anymore. But celluloid is much more well kept. Lots more things are using it. Celluloid uses the actor pattern, that uses the reactor pattern. And so I decided to create, instead of having separate things for worker processes and PubSub, I created something called Switchboard, which does all of these things together, which is just basically a socket server which handles concurrent socket requests using celluloid. So what it means is that instead of having all these separate gems, I just have one switchboard server which takes all kinds of requests and it lives in the middle, and it can do PubSub, it can forward requests, it can talk to the database. It's concurrent. It can do that PTY thing I was talking to you about earlier. So from the command line, you can get PTY command line access to a Docker container. This is still very new. I mean, I haven't fully released this yet. It's actually on a separate branch. I don't know. I think I might have bitten off a bit more. I can chew with this. It could quite, the switchboard itself could quite easily be a gem itself, and I may do that. Okay. What I like about it is that I've put all of the concurrency in one place, and I've got one pattern, and it's centralized. So I've only got, I mean, you could say it's putting all your eggs in one basket, but it's helped me be more clear about this fundamental concept of concurrency within a path. Guard, I think I've touched on this already, so yeah, I've touched on all of this really already. There's no chef, there's very little, you literally, all you have to do is git clone, make sure you've got Docker and Mongo installed, and then bundle exec guard. And guard watches gemfile, the web server, switchboard, which we were talking about earlier, and Gardener, which it's the thing that, so switchboard is the central server, which listens to things, and Gardener is basically like a daemon that runs on all the pods, on the controller, just runs on every machine that's in this distributed pass system, and sends information back, sends job progress, sends uptime reports, all of that kind of thing. So this is what I've always wanted when I was working on these other systems. It's like on these other, like on Deis and OpenRuco, like you change the line of code, and then you'd have to SSH into something, then you'd have to manually restart something, and then you'd have to separately tail logs, and it just, everything was everywhere, and it just to even do any development just took so long. Whereas here, you've just got one command, you've just got one stream of logs. It automatically reloads the right files when you change them. It's just so much easier. Because I think that the development environment is as equally important as the production environment, because that's where all the work gets done. Right, I think this is the last slide. So what I don't have is user authentication. Yeah, there's no concept of user, so it's completely, it's completely open. Anybody can use it. I think I'll soon put single user authentication, so something just like a one API key or something like that. So there's one user and you just share that one user with different people. Maybe it'll stay like that forever. Again, just trying to keep it simple. Fog. Now this is another thing that attracted me to doing all this in Ruby, is that with all of these other platforms of service, you have a separate code for provisioning on different things. So one of the things I want to be able to do with P's is something like P's, admin, pod, scale. So a pod is something that you put all of your P's in, something you put all your Docker containers in. And a pod, I want to be able to run, so a pod can run on VirtualBox, it could run on Docker. So Docker in Docker is a thing. You can have Docker containers inside Docker. So pods could live on DigitalOcean, AWS, on Rackspace, all of these things. And Fog is a single gem that just wraps all of these APIs. So all these other passes have separate code for you to provision your infrastructure on AWS or DigitalOcean or whatever, and each one has to be written itself. I'm hoping that with Fog, there is literally, that's it, you plug in Fog, and Fog has all of the cloud providers in there. And so you just do something like P's, admin, pod scale, and then some token that Fog recognizes. You provide your API credentials for that service, and you could provision a new pod. P's could be hosting Docker containers on AWS, some on AWS, some on DigitalOcean, and you probably don't want to do that because they're in different data centers and the latency. But the point is that Fog is just a nice way of abstracting that, so you don't have to write new code every time you want to create a new provision. And this was touched on earlier about auto service creation. It'd be nice to have be able to do this thing: P's, add-ons, add Postgres. So I'm never going to be actually allowing you to provision an actual Postgres server or something like that. If you set one up and you provide root access to it, then this command can create a discrete database purely for your app. So then all you need to do is install Redis or Postgres somewhere else in your data center, provide the root access details, and then you'll be able to create a little Redis database or Postgres database for an individual application, and delete that database, make that database bigger, things like that.
Why wouldn't that be part of P's?
Why wouldn't it?
Yeah, most all apps, I'll say, have a database. So why wouldn't that be part of?
Yeah, no. What I mean is the provisioning of the actual database service would be part of P's. So there's not going to be a command that says P's install Postgres or something, which is what you get with Deis and OpenShift. it'll actually make a cloud-friendly, scalable install of Mongo or Postgres with the click of a button, with very easily. I won't do that. All I'll do with Peas is that if you've got that installed somewhere and you've got the root access details, then Peas on your behalf can create new database instances within that.
So the question would be, why wouldn't Peas also enable database creation?
Just purely because I just want to keep it simple. I mean, maybe I would get around to doing something like that.
Sure.
Yeah, but I mean, that's one of the things that what Peas is not the same as the others. It's not going to be this all singing, all dancing thing. It's going to try and keep it as simple as possible. You know, the absolute minimum for your own private Heroku. I think that's it. Thank you. Yeah.
We've got links to the Peas project. Is it open source?
Yeah.
Is there a link to
I forgot.
I would put it on.
GitHub/Peas.
Yeah, Tom BH was /Peas, yeah.
I'm pretty sure it's actually on Meta. I was on the Meta page actually. Yeah.
Have you looked at Doku and evaluated that at all?
Yeah, well, because Doku is just basically build packs. I mean, so it's really a single Docker instance.
Yeah, and it's not the server, I know it's not the PaaS stuff, but I don't know whether you use that as kind of a thing and build the PaaS stuff.
At the moment, it is. So the interesting thing about Docker is that it has this thing. It has so Docker uses something called build step, which is a Docker container, which does the actual compiling with the build pack. So build step it has what's called a seeder-ish stack. So it's Ubuntu. It has all of the kind of dependencies needed to build that Heroku uses needed to run all of its build packs. But it's massive. And I'm hoping to not be able to use that or something. But the thing about Doku is that it differs from all of the other passes in that it doesn't create slugs. So every other build step process, every other build pack compilation, its output is a slug, which is a small, maybe 50 megabyte tar. The output of build step in Doku is a Docker commit, so a Docker image. So it's a peeled off image of build step. So it's a massive, like 900 megabyte, although it uses this concept, the Git-like concept of building on other commits. But what that means is it's much harder to pass around a distributed infrastructure, because it means that to run that you need all the dependencies.
Yeah.
So it means moving all of that around every single pod, or distributed node, or whatever the concept is. So when I fully move to using pods and distribution and stuff, I'm going to have to stop using Doku's concept of images and actually move to proper slugs, because slugs can be moved around the system.
This seems like an amazing labour of love, and it's very impressive. But firstly, did you ever catch a bus? And secondly, are you actually using this yourself?
Did I ever catch it? Yeah, well, I haven't got a bike with me, so I'm catching a lot of buses. And every time I pass a bus stop, it's like that nag at the back of my mind. Like, oh, I've got to do that thing. Yeah. Like, it's hard going past bus stops. Yeah. I get that. I have an install of it myself that you can get pushed to at peas.demo.com. I wouldn't go to it at the moment. I'm hoping, so with the next release, what I'm going to do is have this userless install at peas.demo.com and have it as a link at the top of the README saying that this will be set every 24 hours and just allow people to like kill it. So yeah, I do actually have a live install on DigitalOcean that you can push to and runs apps. But oh yeah, but what's been holding me back is it doesn't have any database. Yeah, and it's surprisingly hard to find any kind of relevant or useful, meaningful application that doesn't use a database.
So you're going to go full circle and do your original objective, or is this now taken over?
I don't, well, I mean, I didn't mention that for a reason, because it's still there, it's still a desire. I'd like to think I would, yeah. I suspect that, I mean, the thing is that I thought the bus thing was going to be the big thing, and then I got obsessed with this Dharma box idea, overthrow Google, and then the thing that's actually got me onto Hacker News is peas. So ironically, it may turn out, you know, if I could be, you know, if my salary was paid for just programming peas, then
It seems very much like Inception with different layers, and maybe you'll come back out of those layers and get the original.
I would hope so, you know, it could be years though. But yeah, that's the plan, retracing the steps, build the bus thing, catch that bus, go back to that.
Provision itself or peas?
Say it again, sir?
Peas Docker itself.
Well, again, this is another thing. Deis made a big point of dog fooding. Like, Deis itself is self-hosting. Again, I think that's unnecessary.
Voodoo.
Yes.
Especially when it ends up going on something like Rackspace or anything that's already virtualization inside virtualization.
Like Inception, just,
Yeah.
you know,
Yeah, so I'm saying Inception, that made me think that.
So you did build the bus stop app. Where would you put the bus stop data? Would that be hosted on Postgres database running in a Docker container managed by Peas, or how would you do that?
I'm not as into Docker as a lot of people. I tend to not use Docker if I don't have to. This is the thing. Like, the first time I ever used Docker pulled something. It took fucking ages. And I got so there was this thing. It was a Travis clone. So Travis CI. What's it called? Strider. So it's Travis built in Node.js. So you can run your own tests on your own server. And they have a Docker image. And I thought, oh, I can't be bothered to like do all the installation instructions myself. I'll just do this Docker pull. Everyone's talking about it. It took bloody ages because of all these layers, and it was pulling Ubuntu down.
It's always amazing. So they run.
Yeah. I mean, that was in the early days. I think their registry was a bit slow. But the irony is that whilst that was happening, I read the installation instructions, apt-get installed, and I was up and running with the installation instructions before Docker had pulled the image. So it's not always good. With the bus thing, I think I would just do apt-get install Postgres.
But the thing, I think what we're thinking, our thing we're working on is how useful it would be to be able to use Docker containers for the database in terms of Postgres upgrade. You want to check that your data is properly migrated when you upgrade to a new version of Postgres. And so you want a way of storing the data and running a new application container against that data and checking that it's properly migrated to the database, the data is served. So that's the sort of thing
That you're looking into, yeah. So you come across this concept, the idea of data containers. So containers that are used purely for data. So you're mounted.
You're taking the volume from another container and seeing
So you're right, yeah. I mean, I've not done any of that. I mean, so checking your data against a new version of Postgres, that's much harder. You can't really do that without Docker. I mean, why
no,
can't
it's
you?
just that no one seems to talk about it. The Docker examples do contain a Postgres Docker file recipe.
Right.
They sort of gloss over the important issue of where the data is stored and how it's backed up. And that's the thing that we're trying to
What does Postgres do themselves when they upgrade? How do they
Right, yeah, I
validate
guess,
that, I mean,
yeah, they just take they do a SQL dump and then
yeah,
import it into a university database, but
yeah.
we're looking at ways of making that faster and not having to do that long-winded
Yeah.
dump and then restore step.
Can you
Also,
not just replicate it out to an upgraded version and then promote that and simply kill off the previous version?
but you can, if you want to test it, I suppose. You want to be able to test that
Yeah, but
version
you
of
just wouldn't
database.
you just wouldn't switch any data traffic over to it until you weren't happy that it was. I'm not a Postgres expert by any means.
Yeah.
If it behaved anything like MySQL, it's reasonably easy to put
Yeah,
a slave into the mix, provided you've got a sufficient snapshot. Bring that up, use that accordingly, and then
Yeah.
promote it at the point you're happy with it. Because you want to do all that with downtime. And the thing with Docker and things like this, I'm very hesitant about it in certain areas, and certainly databases would be the one area that I was massively hesitant about it. If I'm touching a database, I want to just slow down a little bit. I want to put my beer down, just have a think about what I'm doing, and the concept of command line, whatever it might be, Docker drop database previous or whatever, just literally scares the shit out of me.
Right.
I think I'd go to a whiteboard first before I did anything else.
The thing we're doing is we're using ZFS, which has this snapshot facility. So you can take a snapshot, and
Yeah.
from then on it's copy on write,
Yeah,
and the files change. So you can test whether migration is successful, and if it's not successful, you can the live container continues to use the snapshot of the data, whilst the upgrade is copying and writing during the upgrade it's doing copy on write to check that the data is upgraded properly.
Do you work for Hybrid Logic?
Yes.
Yeah, Luke used to work for you.
I was talking to
I heard ZFS and database snapshots.
There could only be one company in Bristol.
I remember the same conversation I had with Luke in my office a few months back. So
So we've just switched. We pivoted. Luke's original product was about ZFS on FreeBSD, using FreeBSD jails, and now with I think one of the problems, Mike, did you say is this right? The problem is the compatibility, finding applications.
No one uses FreeBSD. That was the problem.
So this is the way.
my issue with that specifically, what I know you guys are trying to achieve is not so much with the technology to do with how it's actually achieving those things, but it's to do with the design patterns of relational databases and ensuring integrity of data.
Yeah.
Because for example, ZFS is fantastic, but if you roll back an instance where a live change has come in the gap where you roll it back, and your website is designed such that you've linked IDs directly to something, and your design pattern is such that your IDs are sequential, then you just come and search somebody else's data direct out to that new customer that's previously. It's a very difficult challenge.
But
Yeah,
I guess
it really
the database is designed to be atomic, so you know, at any point in time, you should be able to guarantee that the data is in a consistent state. Yeah, probably not.
No, it's a big challenge. I don't have the answers. I just know some of the problems.
It's interesting. We're using an OpenShift. I don't really know much about OpenShift, the big project. We're using part of it called Gear.
No, I don't know. I've heard that rings a bell.
And that's got a facility for linking containers together, which is something I've been looking at.
All right, yeah. The networking.
Yeah, so you can say when the web application inside the container tries to reach database port 1, 2, 3, 4, 5,
It means
it's automatically routed to port 4, 5, 6, 7 on the host machine.
that's very handy.
And then it handles,
So is that like Amazon Cloud Formation? So you can sort of bring up a whole group of things together and queuing them down together.
Yes.
The other thing is that code for fog sounds like it's very much similar to what's it, Vagrant? Because basically that's talking to provisioning out, and that's written in Ruby, isn't it? So
Yeah.
so you might be able to borrow a whole like
used in the same way as Docker at the moment. Just for throwing, if you just want to host something that you usually host on Heroku on a single machine, it functions exactly the same as Docker. Thanks.